any angle that you draw is gonna fall in one of these four quadrants, okay? Now, suppose an angle is in this quadrant, okay? Or an angle is in this quadrant, okay? It makes a difference. So let's say you want to find the cosine, right? It makes a difference which angle, which quadrant the angle falls in, because when you find the trig values, they might either be positive or negative. And how do we remember where it is positive and where it's going to be negative? Well, it's a mnemonic. This is a memory, a memorizing method. All students take calculus. So basically, you know, everything goes in a counterclockwise form. So it's like this: all students take calculus. Okay? So what does all this mean? Here, for the first quadrant, A stands for all. So all functions are positive there. So if an angle falls in the first quadrant, and if you take the sine of it, it'll be positive. The cosine will be positive. The tangent will be positive. Okay? The next one for S, that stands for sine. That means in that quadrant, the sine is positive. The rest, the cosine is negative. The tangent is negative. Okay? The next one, the tangent is positive. Okay? That means the sine is negative and the cosine is negative. All right? Well, what do you think in the fourth quadrant? Cosine is positive, and the rest of them are negative. So sine of theta is negative, tangent of theta is negative. All right? So how do we use this? Suppose you have an angle of 240 degrees. Which quadrant does that fall in? 240 degrees. Is it in quadrant 1, 2, or 3? It's in quadrant 3. All right? Now, so now if I wanted to find the cosine of 240, would that be positive or negative then? Negative. Okay? All right. So now, if you have just any old angle and you wanted to find the trigonometric values of that angle, okay, it's a three-step process. First, you find the reference angle. That should take you about 3 seconds. Then, you evaluate the trig function of the reference angle, and then you determine the SIGN sign. All right? So let's do one. Okay, here we go. Sine of 135, right? What would be the reference angle for 135? 45, right? Yes? Are we all in agreement? Okay, so reference angle, all right, is 45 degrees. So that's step 1. What does step 2 say? Evaluate the trig function for the reference angle. Now, I want sine of 35. What I do is I try to find sine of 45, okay, because that's the reference angle. Now, what would be the sine of 45 degrees? The sine of 42 degrees. It's root 2 over 2. Okay? The side that 45 degrees faces is root 2 over 2. And the third is determine what sign it has. Now, in what quadrant is 135 going to fall? 1 or 2 or 3 or 4? Quadrant 2. In that quadrant, is sign positive or negative? Positive. So then, sine of 135 is equal to positive root 2 over 2. Okay?
You have to write positive or positive?
No, you don't have to write positive. Okay. So let's recap here our angles. All right. How many possible angles do we have? We have a 30 degree, we have a 60 degree, and we have a 45 degree, right? Those are the possible special angles. I'm not talking about the quadrantal angles, 90, 180, and so on. What are the radian equivalents of these? Pi over what for 30?
3.
Pi over 6, pi over 3, and pi over 4. So those are all the possible angles. Okay? What are all the possible sides? For the 30, 60, 90, right? The possible sides are 1 and root 3. And for the 45, it's root 2. Okay? So those are all the possible sides. Okay? Now, how are we going to use this? If I need to find, so let's just do a random one. If I need to find, let's say, the sine of 60 degrees. Now, between the 30 and the 60, is that the bigger or the smaller? That's the bigger. Does it face the bigger side or the smaller side? The bigger side. So what side would that be? Root 3. Over 2. Right? Root 3 over 2. Well, it's like this, right? So it'll be root 3 over 2. Yeah. All right. So let's go back here. And let's do this one. Here we have cosine of 7 pi over 3. All right, so what's the first step is to find the what? The reference angle. And for this one, it's how much? The reference angle. If it's given to you in radian, you keep it in radian. So what's pi over 3? If it's given to you in radian, you have to give it in radian. So now look, this is pi over 3. It'll stay as pi over 3. So there is minimal thinking involved for this one. If it was 7 pi over 6, what would the reference angle be?
Pi over 6.
Pi over 6. Okay? Now, number 2, we need to find cosine of that reference angle, pi over 3. Okay, so here we go. Is pi over 3 the smaller or the larger angle?
Larger.
The larger. So which side does it face? The larger, which is root 3, right? But is cosine the side that it faces or the one that's horizontal? Horizontal. It's horizontal. So if it faces root 3, what's the horizontal?
1.
If it faces root 3, the horizontal is 1. Over what? 2. Okay? Now, what quadrant does this lie in? Let's see. 7 pi over 3, I write it as a mixed number. That's 1 and, that's 2 and 1/3 pi. So what quadrant does that fall in? 2 and 1/3 pi, which quadrant?
4. 8.
So 2 pi, I go here, 1/3 pi is here. Okay, so it's quadrant 1, not A, B, C, D, but 1, 2, 3, 4. Okay, so it falls in quadrant 1. Now, is cosine positive or negative there?
Positive.
Positive, so the answer is 1 over 2. All right? Yeah.
Isn't this like what we should know for our values? For percentage?
Well, no, because, so reference angle is pi over 6. So let's now find tangent of pi over 6. All right. Is pi over 6 the big one or the small one?
Small.
The small one. So it faces the small side. Now, tangent is the vertical over the horizontal, right? Tangent is always vertical over horizontal. So if it faces the small, then this is 1 over, what's the other one? One side is 1, the other side is root 3.
That's root 3 over 3.
Root 3 over 3. Okay, so what's the tangent? What quadrant does this fall in? 5 pi over 6.
Second one, so it'll be negative.
5 pi over 6 is in this quadrant, right? because it's just short of a pi, so it would be negative root 3 over 2. Over 3. Okay? The sine of pi over 3. Okay. So here, let's do cotangent of pi over 3. What's the reference angle? Pi over 3. All right, so let's find cotangent of pi over 3. What would that be? What's cotangent of pi over 3? Pi over 3 is the larger angle, so it faces the larger side. Now, cotangent is x over y, right? So if the larger side is the y, that's going to go here, and what's going to go above? How much? 1. So this will be root 3 over 3. Now, what quadrant is this in? This is 1 and 2/3 pi. So look, here is 1 pi. Where do I go for 2/3 pi?
Just the next line.
Here. Okay? So it's in quadrant 4. Is cotangent and tangent positive or negative there?
No, cotangent, tangent, or negative.
Cotangent and tangent are negative there. So the answer is negative root 3 over 3.
It was the same answer as for C?
Uh-huh.
Okay.
All right, secant of 120. What's 120? What's the reference angle for 120? Okay. What's secant of 60 degrees? It's the opposite of the cosine. Okay, so look, 60 degrees is the larger side. It faces the larger side of root 3. But this, okay, look, listen. Secant is like the cosine, and it's the horizontal side that we want, right? So if this is 60 degrees, the vertical side is root 3. The horizontal side is 1, okay? So this is going to be the reciprocal of 1 over 2, 2 over 1, okay? Now, what quadrant is 120 in?
The left on the top.
Second quadrant. Is secant positive or negative there?
Negative.
Negative, so it's negative 2. All right, next one. Cosecant of negative 3 pi over 4. What's reference angle? Okay, now, raise your hands to answer this question. What I want to do now is I want to find the cosecant of pi over 4. So now, raise your hands to answer this question. All right, cosecant, is this like sine or cosine? Thank you for raising your hand. Now, does that mean, okay, so pi over 4, what side does it face? Yeah.
It faces the smaller leg.
Well, okay, so pi over 4, it's got equal legs.
I mean, oh,
right?
It's the 45. So it faces. Wait, then it faces the same, like.
It's 1 over root 2. But if this is the cosecant, then it would be root 2 over 1. And okay, so now this is negative 3/4 of a pi. Negative 3/4 of a pi is in this quadrant, right? What quadrant is that? Quadrant 2. I'm sorry, quadrant 3. And tangent is positive there, so cosecant will be negative, so this is negative root 2. This negative is independent of that negative. Okay, so these are your homework questions for next time.